Okay, in this video, we're going to derive an expression for the inverse, a derivative for the derivative of the inverse hyperbolic tangent function. And again, as we pointed out in our previous videos, the way to proceed with this is to realize that all of these inverse hyperbolic functions can be expressed in logarithmic form. So, for example, if we said, well, let's just call this y, then y has to equal 1/2 the natural log of 1 plus u divided by 1 minus u. And what we want to do is find an expression for the derivative of this, for the inverse hyperbolic tangent of u. And of course, d of this with respect to x, that's the same thing as dy dx. And dy dx you should be able to find because all we have to do is perform a logarithmic differentiation. This might be a bit more of a challenge than what we've had in the previous two videos. So let's get started and see what we can find. Y equals this, so dy dx will equal 1/2 of 1 over, of course, the set of logarithmic sign. So we're going to be taking the reciprocal of this expression. So we will have 1 minus u divided by 1 plus u, and then we multiply by the derivative of this. And that's going to be this times the derivative of this, because this is going to be du dx. So we have 1 minus u du dx. This times the derivative of this minus this times the derivative of this, which is minus u dx, divided by this squared. Okay, let's see what we have here. We have outside here these two cancel, but we'll leave it right as it is for now. We'll just say this simply equals 1/2 1 minus u divided by 1 plus u. And then we're going to factor out this du dx from here. So this would just be 1 minus u. And here we have a minus times a minus, so that's a plus. So we're going to have plus 1 plus, this will be a plus here, so this will be plus 1 plus u divided by 1 minus u squared. And this is going to be divided by du dx. Okay, let's just see before we go on here. We factored this out. That's here. This is 1 minus u. Here we have a minus sign, but here we have a minus sign. So that becomes plus, and this should just be 1 plus u, which is what we have here. But it looks like up here, these u's are going to cancel out. And then here I have 1 plus 1 is 2. I've got a 2 down here. So let's see. This will be equal to 1 minus u divided by 2 times 1 plus u. That's just writing this over here. And up here we have 2 divided by 1 minus u, this is 1 minus u quantity squared, times du dx. And the 2's will obviously cancel. And let's see, this and this will cancel. So what do we have left? Up here we just have 1 over 1 plus u times 1 minus u. This was 1 minus u squared, but that canceled out with this 1 minus u up here. Du dx, we can multiply these, and we're going to have 1 over, looks like 1 minus u squared. Du dx. And that is what dy dx equals. That's what we were solving for all along here, was dy dx. But the way this is set up, dy dx is the same thing as this, taking the derivative of this with respect to x. So we will have then that d dx of inverse hyperbolic tangent of u equals 1 over 1 minus u squared du dx. And so there it is. It's not too difficult to get. But again, we had to remember that these inverse hyperbolic functions, they can be expressed in logarithmic form, and then you end up doing logarithmic differentiation to get an expression for the derivative of the inverse function. Okay, that takes care of that. Come back, and in the next video, we'll see if we can find an expression for the inverse hyperbolic cotangent function. We'll do that in the next video.